Hello everyone, myself Jatin and I am going to present on the topic visualization of various crystal structures using SIP5. So to begin with, we are starting with barium titanate structure. Now barium titanate structure is depicted here in the form of a unit cell with the fractional coordinates shown. Barium at the corners with the fractional coordinates 0, 0, 0. Due to the unit translation, all the barium atoms are present at the corners. Titanium is present at the body center with the fractional coordinates half, half and half, while the oxygen atoms are placed at the face center with the fractional coordinates 0 0.5, 0 0.5, 0 0.5, 0.5, 0.5, 0.5, 0. Now to begin with, let's see that how electric field affects the polarization of the entire unit cell structure. Now, these are the series of unit cells given wherein how the electric field which is in upward direction affects the crystal structure. In the coming slide, that is moving ahead, in this slide, we will be observing that how the electric field when applied in the downward direction affects the crystal structures. Now, to explain how the polarization is induced in the crystal structure due to the electric field that is depicted in the hysteresis loop. Now this is a hysteresis loop which is nothing but a graph between the polarization versus electric field. Now here those different unit cells are depicted in the form of labels exhibited in the graph. Now here, owing to the structure 1, you can see that initially there is no electric field. And since there is no electric field, the structure exhibits a perfect octahedral geometry, thereby leading to an unpolarized state. That means there will be no polarization. But as the electric field is applied in upward direction, what happens is that the polarization is induced due to the change in the geometrical structure from perfect octahedral to a distorted square pyramid. Now here what happens is the titanium ion moves in the upward direction owing to the c-axis, and it tries to reach to the face center at the top, leading to structure 3. At this point, titanium can no longer move in above direction, thereby leading to a maximum saturation polarization. Now further, when electric field in the same direction is decreased, what happens is that the titanium ion tries to approach it at its original position owing to structure 4, and further eventually when the electric field is 0, it comes back to its stage, that is at state 5. Although there will be some remnant polarization remaining due to the initial electric field. Furthermore, when the electric field is applied in downward direction, what happens is that the titanium ion now moves in the downward direction, thereby leading to structure 7 and eventually to the structure 8, wherein the titanium has reached to the bottom face center. Now further, when the electric field is again decreased along the same direction, what happens is that the titanium ion will try to come back to its original point, that is at the body center, thereby leading to structure 9 and 10. And as electric field is again continued in upward and downward direction, the loop is completed and we get a complete hysteresis loop. Now the motion of titanium ion is shown in the unit cell, which you can see here. You can see how titanium ion is moving initially in the upward direction, coming back to its initial point, going down, and then again coming back owing to the direction of the electric field. Now, this was all about barium titanate structure. Now we will be observing the different kinds of unit cell structures which are shown in the given slides. So let's first talk about calcium telluride structure. Now calcium telluride structure exhibit a rock salt structure, NaCl type structure, wherein the edge length of the unit cell is 6.356 angstrom units. How the ions are distributed is that the calcium ions, which are shown in blue atoms, smaller atoms, are present in the octahedral voids in the array of FCC lattice exhibited by the tellurium atoms, which are shown in green color. The fractional coordinates of calcium is shown as 0 0.5, 0 0.5, 0 0.5. That is the body center, which is nothing but an octahedral void. And also the edge centers, that is 0 0.5, 0, 0, 0, 0.5, 0, 0, 0, 0.5. Tellurium exhibits FCC lattice, so its fractional coordinates will be 0 0.5, 0 0.5, 0, 0.5, 0, 0.5, 0, 0.5, 0.5, and also at the corner position, that is 0, 0, and 0. Further, let's talk about the next lattice structure. Now this is a gallium phosphide structure. Now gallium phosphide structure, you can see it exhibits a zinc blend type of structure, ZNS type structure, wherein the H length of the unit cell is 5.48448 angstrom units, where the distribution is such that the phosphorus atom forms an array of FCC lattice since it is a bigger ion, and gallium being smaller ion is present in the alternate tetrahedral voids. Now the tetrahedral voids, they can be these tetrahedral fractional coordinates of these tetrahedral voids are given in the CIF file. However, we can just see, like in case of gallium, the tetrahedral void fractional coordinates can be given by 0.25, rather 1 by 4, 1 by 4, 1 by 4, and accordingly we can further continue. Potassium oxide. Now in potassium oxide exhibits an anti-fluoride structure, that is Na2O type structure with the edge length of 6.449 angstrom. And how the ions are distributed? So the ions are distributed such that again oxygen being larger atom, relatively larger atom, forms an array of FCC lattice, and all the tetrahedral voids are occupied by the potassium ions. Cerium oxide. Cerium oxide CEO2 exhibits a fluoride structure wherein the calcium forms a bigger atom. That is, a cation is bigger in this case. The unit cell dimension is 5.411 angstrom units. And how the atoms are distributed is that the cerium here forms FCC lattice, and all the tetrahedral voids are occupied by oxygen. Finally, let's talk about a metal solution, that is a gold zinc metal solution. In this solution, you can see it forms a typical cesium chloride type of structure, where in the edge length is 3.519 angstrom units, and how it is distributed is that the gold atoms are at the corners while the zinc is present at the body center. This thing can be reversed, where the zinc forms the corner and gold forms the body center. Thank you.